In this tutorial, we're going to talk about solving systems of equations using substitution. I'm going to start you off with a very basic problem just so that we can understand the principles of what we're doing. So let's say this is my system. I have two equations, one being y equals 3x plus 1 and the other being y equals 2. So what's key to understanding here is this y here and this y here are the very same exact variable, which means if y is 2 here, y can also be 2 here. So how does that look when I do that substitution? So now what I did is I rewrote those two exact same functions and I highlighted in orange the variable that they share, the variable that's in both of them. Because when that happens, these are now, oops, wrong color, these are now interchangeable. Okay, so whatever this y is equal to, I can replace this y with it, and vice versa. So what I'm going to do is I'm going to go ahead and replace the first y up here, this one right there, with 2, since that is also what it's equal to. So let's see what that looks like. And there we have it. So everything on the right-hand side of my equation stays the same because nothing was replaced, but I replaced the y with something else that it's equal to. So that's the concept behind substitution. Let's take a look at a couple other examples that are like this. Okay, so in this system we have y equals 6x minus 11 and negative 2x minus 3y equals negative 7. So first of all, we want to try to figure out what variables that they have in common. And it looks like they both have an x right here, and they both have a y. Okay, so we want to use the relationship between one of those to help us with substitution. And the rule of thumb is that we want to pick the variable that is possibly already by itself. So if I look at the x's that I have here, this one has a 6 with it, and this one has a negative 2. So that doesn't follow along with that rule of thumb. If I look at the other variable, I have the y's. This one has a negative 3, but this one is all by itself. That's what we're looking for. And that's going to become really helpful when I do my substitution. And let me show you why. The y here with the negative 3, I'm going to outline in green, just like that, so that it matches the colors. Everything that the y value on the top represents, which is the 6x minus 11, I get to plug in right here for y, because that is what y is equal to. They are the same exact thing. So I'm going to rewrite this function, or this equation I should say, and I'm going to replace the y. So we're going to write the negative 2x first. That doesn't change. Minus 3. And now where y is, I'm going to still keep this in green, but I'm going to open a pair of parentheses because that's a lot of stuff I'm putting in for y, and we want to be really careful. So the 6x minus 11 goes there, and then on the right-hand side of my equation, I have negative 7. Okay? So that's the concept of substitution. Let's see if we can actually solve this. And when we're solving these systems, we're looking for a couple things. The first thing that we're looking for is that we have an answer, an actual number answer for each variable. So when I'm done, I should have y equal to some number, okay, and then I should have x equal to some number, because those are the two variables that I have. So we need to keep those ideas in mind as we're doing this, because just because I solve for one of them does not mean that I've solved for the other, and so we're not done. Let's go ahead and go back to the problem that we were working on. And before I can do anything, I've got some distribution that I need to do right here. This 3 is being multiplied by both the 6x and the negative 11. So I'm going to bring down the negative 2x, and I'm going to use the negative sign when I do my distribution, so that way it's already taken care of. So negative 3 times 6 is negative 18x. Okay? And then negative 3 times negative 11 is positive 33. And then I'm just going to bring down everything else like that. Okay, so now we're going to try to isolate the variable that we have right now. And as you can see, there are no more y's, just x's. So let's go ahead and combine anything that we can. Negative 2x minus 18x is negative 20x. And I'm going to bring down the plus 33. I haven't done anything with that yet. And that's equal to negative 7. What I would do next is we're trying to get the x variable by itself. So I'm going to subtract 33 here. It's not attached to an x, so it's easy to get rid of. So those cancel. And then I'm going to bring everything else down. So the negative 20 gets brought down with the x. And negative 7 minus 33 is negative 40. And the next thing that we do here is we're going to divide both sides by negative 20, which means I now know what x is equal to. These 20s are going to cancel out, and 40 divided by 20 is 2, and a negative divided by a negative is a positive, so x is equal to 2. So there's one of my solutions. Once you have the first solution, the rest of this becomes very easy. So I'm going to go ahead and pick one of the functions that I started with. It doesn't matter which one that you choose. But the first one looks a little simpler, so we can start with that. And I'm going to do this in the green color so that we know that we're solving for y, because I've already solved for x. So I'm going to use this equation here. And I'm going to write y equals 6, and we just solved x. So guess what I get to replace x with? I get to replace it with 2, because that's what I just solved it for. And now I'm going to bring down the minus 11, and we are going to solve using our order of operations. So I have y equals 6 times 2, which is 12, and then minus 11, and I know now that 12 minus 11 is 1. And that's my answer. I now have both solutions. And there is a way to check your answers to see if they're correct. And I'm going to do this on the next page so I can keep everything here. Since I just used the first equation to solve for y, I'm going to just use the second one so you can see the difference. So let's see. Let's turn the page and see. Okay, so this is how we're going to check to see if our answers are actually right. What the process is I'm just going to go in here, and wherever I see an x, right here, I'm going to replace it with a 2. And wherever I see a y, I'm going to replace it with a 1. So here we go. We're going to do negative 2 times 2 minus 3 times 1 equal to negative 7. So now we can go ahead and multiply. Negative 2 times 2 is negative 4. Negative 3 times 1 is negative 3. And then I'm going to bring down the equals negative 7. Now I can combine these terms here. Negative 4 minus 3 is negative 7. So here's what should happen. If your answers are correct, you will always get a true statement. Is negative 7 equal to negative 7? Yes, it is. So that's how you know that you did your problem correctly. I'm going to do one more on the next page. I'm going to work it a little quicker. Or not quicker, I should say, but it shouldn't be nearly as hard to get this problem started. So here this system definitely looks a little bit more complicated. The rule of thumb that I showed you, let's see if we can make that work here. I've got a pair of x's. I've got an x here and an x here. Are either one of them by themselves? No. One of them's got a negative 2. One of them's got a negative 7. So let's take a look at the y's. This one's got a 6, and this one's got an 8. So here's the thing. If the rule of thumb doesn't work, okay, then we have to make one of our functions look different so that we have a variable by itself. And you can choose whichever one that you want. So let's say I choose to work with my first function, and we can solve it for y. I think we're more used to seeing that, so let's go ahead and solve for y. So what we're going to do is I'm just going to recopy the equation over here. and I'm going to get y by itself. So the first thing that I'm going to do is I'm going to add 2x to both sides. That way it can cancel out. So I'm going to cancel those out, and I'm going to bring everything else down. So 6y and 6 and 2x are not like terms, so I'm not going to touch them. I'm just going to copy them back down. We can't combine them. And then the next thing that we can do to get y by itself is divide both sides by 6. And when you divide one thing by a number, you have to divide every single other number by that same thing. Okay? So here's what it's going to look like. I'm going to look like y equals, and 6 divided by 6 is 1, and 2 divided by 6 reduces to 1/3, because 2 and 6 are both divisible by 2, and then that has an x with it. So now I have y all by itself, which means in the second function up here, I get to replace this y right here with 1 plus 1/3 x. Alright, so let's go ahead and see if we can get this started. I'm going to do this on the next page as if I was starting a brand new problem. Okay, so just like as if I had a brand new function, I now have the y equals 1 plus 1/3 x and the same second function. And remember that these y's are the same exact y's. So what I'm going to do is I'm going to take this right here and I'm going to plug it in to this y. So this is just like the problem that we did before. So let's see if we can move through this a little quicker. I'm going to go ahead and write down my negative 7x plus 8. And then I'm going to open parentheses for the 1 plus 1/3 x. And then I have equals negative 5. So now what we're going to need to do is we need to distribute the 8 here and here. Okay, I'm going to have negative 7x. 8 times 1 is 8. 8 times 1/3 is 8/3. And that's an x. And that equals negative 5. Okay, so we do have a couple x terms. And a quick way, if you guys don't like working with fractions and combining them, take a look at its denominator. So this 8/3 right here has a denominator of 3. If to cancel that division by 3, I would have to multiply this by 3. So what you can do to the entire thing is multiply everything by 3, and that fraction will go away. So let me show you what that looks like, because I think that would be a really good idea for this one. So negative 7, the first number here, times 3 is negative 21x. The next term is 8. 8 times 3 is 24. And 8/3 times 3 is just 8x, because now that 3 cancels out. And negative 5 times 3 is negative 15. So now no fractions. That's pretty nice. So I've got an x term here and here. So negative 21 and a positive 8 is 13. And that's negative, because the 21 is bigger than 8 and it's negative. Plus 24 equals negative 15. Okay, there are no more x's to combine on the left-hand side, and there's nothing to combine with the 24 on this side, so I can finally move him over. So those will cancel. Bring down the negative 13x. Negative 15 minus 24 is negative 39. I now divide both sides by negative 13. And these 13's cancel, and I am left with x equals, and 39 divided by 13 is 3, and a negative divided by a negative is positive, so x is equal to 3. Remember, we are not done yet. That is just one of my answers. So we're going to go back, and we are going to find out what y is. So just like before, I'm going to use the first equation just because it looks a little nicer. Once again, if you don't want to work with the 1/3, you don't have to choose this function. So I'm going to have y, and let's see, I'll put it in gray so that we know what we're solving for, equals 1 plus 1/3 times x, which was the 3. Okay, all right. So at this point in time, I'm then going to have y equals 1 plus, and 1/3 times 3, this is 3 over 1, and those are reciprocals, which means that it's just 1. Okay, which then means y is equal to 2. And you can also check this by doing the same method as before. And there we go. That will conclude this tutorial.